Live from Utrecht, this is the fan Wirdum Sjorsnado.
Hello.
Episode 4. We're
Indeed.
Back.
Yes.
Sjors,
We made it.
so far, so good.
I think I'm still alive.
Do you think this is gonna be a one-taker?
I hope so.
Let's hope so. This would be a miracle if we can get this one right at once.
Let's see.
What are we gonna be discussing today, Sjors?
I think you wanted to talk about script.
I want to talk about Miniscript, to be more
Miniscript,
specific.
In fact, yes.
That's what I want to know everything about, Sjors. So
But
you're
what is
gonna
that?
help me.
Okay.
Is that the deal?
Sounds good.
Yes, Miniscript. It's a project, I guess that's how I would describe it. It's a project by a couple of Blockstream engineers, even though it's not an official Blockstream project. But it's Pieter Wuyle, Andrew Poelstra, and then there was a third name that wasn't as well known, Sanket Kanjalkar.
Yeah, I believe he was an intern at Blockstream
He may have been
at the
an
time.
intern, yes. So they developed this idea called Miniscript. So let's just get into what it is. It's okay. So to sort of spoil what it is a little bit before we get into that, it's sort of a simplified, stripped-down version of Bitcoin script, which is the programming language used in Bitcoin.
Yeah. Or,
So far, so good.
Yeah, or it's a template. Basically, it's a template of Bitcoin scripts that you can use.
A template of Bitcoin script is how you would describe it.
Yeah.
Okay, so let's get started. First things first, script. Bitcoin script.
Yeah, I think 2 episodes ago we explained that it was actually good to add constraints to money.
Right, yes. This was in the Taproot episode. You explained how actually putting some restraints to money would be a good thing.
Right, because
in the context of Bitcoin.
Right, somebody, if you're sending me money, everybody can see that Bitcoin transaction, so you want to make sure, or in particular, I want to make sure that I'm the only one who can spend it. So I'm telling you, give me, make this transaction such that it can only be spent by my public key. And the way that's done is using a script. Even though it's a very simple script and most people use the same script, it is actually a script.
Yeah, and script is actually a programming language.
Yes.
It's a new programming language. It was introduced in Bitcoin, like it didn't exist before, although it resembles something that did exist before.
Yeah.
Which is called Forth.
Yes, it basically, it's pretty horrible. I mean, it looks like it was just.
It's a horrible programming language.
I think so. It seems to be coupled together as an afterthought, but I think it was only later that people realized that you can only change Bitcoin through very carefully crafted soft forks. So you can't just say, let's just start with a draft language and then clean it up later. So it's been a complete nightmare to make sure that language doesn't do anything surprising, anything bad. So a lot of the operations that were part of the language have been removed almost immediately because there were all sorts of ways that you could just crash a node or do other things.
Right, these were removed early on.
Yes. I mean, Ethereum had a similar experience in 2015, right, where complex programs could do all sorts of unexpected things. But Bitcoin had that in the beginning too.
Yeah. So just to remind our listeners, like what kind of restrictions can you put on a transaction? Like what kind of restrictions are we talking about here?
Yeah. So the main restriction would be that only the owner of a specific public key can spend this transaction. I think that's the typical pay to public key hash transaction.
Mm-hmm.
And maybe we want to demonstrate how that works.
Go for it.
Yeah. So it's a stack-based language, and a stack is like a stack of plates. You can put plates on it, and you can take the top plate off, but generally you don't want to just take a plate out of the middle. And this is just easy to implement as a programming language in general. So when people make early computer processors, it was just easier to have a memory where you could only put things on top of it and take the top element off. You didn't have addresses. Like with memory, you have to say which part of the memory do you want. With a stack, you just say put something on it, take something away from it. So the standard Bitcoin script reads as follows. It's very beautiful. It's op-dub, as in double, duplicate, then op hash 160, as in take the 160 SHA hash,
Mm-hmm.
and ripmet hash, then the public key, and then op equal verify. So it's 4 elements: duplicate, hash, pub key, and then equal verify. And if you kind of walk through what that does, Let me see where I have it. So what happens when the blockchain encounters this script? It's going to be in the output of a transaction. So the output of a transaction shows the script that it's locked with and the amount. Now, if you want to spend that, what you do is you first publish what you want to put on the stack, and then you sign it, essentially. Well, actually, you just publish what you want to put in the stack, and that probably includes a signature. So when
by publish you mean generate a new transaction.
Yeah. So the input of your transaction,
yes,
what that actually looks like is basically a couple of things that you're putting on the stack. And what the Bitcoin interpreter will do is it will see the stuff you put on the stack, and then it starts running the program from the output. So given your stack, it starts running the program from the output. So in this case, what you put on the stack is your signature and your public key. Because the original script did not have your public key, it had the hash of your public key. Okay, so we start with a stack that has two plates. Plate 1 at the bottom is your signature, and on top of that is a plate with your public key. And then the script says opt-up. And what opt-up does is it takes the top element of the stack, so it takes the top plate, the public key, and duplicates it. So now you have two plates with a public key at the top of the stack, and your signature is still at the bottom. Then the next code, the next instruction, is op-hash 160. So what this does is it takes the top thing from the stack, which is one of those public keys, it hashes it, and then puts the hash on the stack. So now the stack is...
Oh, you...
I'm trying to interrogate you here.
Yeah, apparently. Now the stack is a hash, and the public key... I didn't keep up.
Yeah, so at the bottom is still the signature, then there's a public key, and then there's the hash of the public key. That's what's on the stack. So the next operation is pub key hash. So that is the hash of your public key again. So now at the top of the stack is 2 times the hash of your public key. And then the next operation is op equal verify. So that basically takes the 2 things off the top of the stack, says, hey, are they the same?
Yes.
So indeed, did you put the hash of your public key? And then the last thing that's left on the stack is only your signature and your public key. And it calls op-checksig, so it checks the signature using your public key. And then the stack is empty, and everything is happy. That's how the Bitcoin program is run, and you can do arbitrarily complicated things. Yeah, you can do arbitrarily complicated things that way.
So basically, this stuff is telling your computer what to do, what to check, see if stuff matches. If it matches, it's okay. If it doesn't match, it's not, depending on whether it should match or not, and that's defined by the code. But notice that's what we're doing here, right?
Yeah, but notice that you don't have to check a signature.
Exactly.
You could just have a script that says, yeah, it's fine, just take it.
Yes. Or you could have a script that says you either need a valid signature or you need 34 invalid signatures.
Yeah, you can do
weird things.
Yes, very strange things.
Okay, so that's kind of the point we're getting at here, I think, right?
Yes, because
the script language is diverse enough to allow for weird stuff.
Yeah, and now the question is, if you're just sending money to yourself, you only need this very simple standard script that everybody's seen a million times. But let's say you're collaborating, you want to do a multisig. Now, there's actually an instruction to do multisig, but let's say that didn't exist. So one way you could do multisig is say the script we just explained with my public key in it, or my public key hash, and then the script we just explained with your public key hash, just in sequence, right? So that if that's executed, I will not repeat the process we just did before, but you essentially start with those, 2 public keys and 2 signatures on the stack, and you run both of these scripts in sequence, and then if both people signed, it's all good. So you have a poor man's multisig.
Right.
But if I'm evil or stupid, I could make this a wrecked man multisig. Sorry for the joke. And that is achieved by, in the middle, inserting an opcode called op-return.
Right.
And the op-return code basically says, all right, stop evaluating this program, you're done. Now, if I had an electronic lawyer that wanted to check that this multisig is what it says it does, or in fact, if you had that lawyer, your lawyer might say, well, I see that my signature is being checked, and whatever the rest of the script does, I don't care. But my signature is being checked, so I'm happy with this. But of course, you shouldn't be happy with this. So your electronic lawyer should see that op return statement and warn you. But the problem is there's a trillion ways in which scripts can go wrong, and that is why you need like a standardized way of dealing with these scripts, and that's where Miniscript really comes in.
I'll read a little fragment from Andrew Poelstra, who I interviewed a long time ago when I wrote an article on this.
Okay.
So the example he gave was, and I'm not going to pretend like I understand everything he said in this quote, but that was sort of the point of the quote for me, that it was exemplifying the complexity of potential ways to mess around with script. Anyways, so the quote was, "There are opcodes in Bitcoin script which do really absurd things, like interpret a signature as a true-false value, branch on that, convert that boolean to a number and then index into the stack, and rearrange the stack based on that number. And the specific rules for how it does this are super nuts." You probably actually follow that perfectly.
No,
well. I don't. Oh, you don't either.
I kind of do, but it's, the analogy would be, you have this stack of plates and you take a hammer and you smash one and then you confuse two and you paint one red and then it still works if you do it correctly. It's completely absurd.
Right. Or another analogy I think you gave before this recording. Correct me if this is not the right way of explaining this analogy, but it's like you have a contract and it says, you're buying this house and these are all the conditions. And then there's a small letter which says, unless there's like 2 commas in a row somewhere in this contract, in which case all your base are belong to us.
Exactly. Except that this will be like the law, right? So the contract doesn't say that at all. It's just that the law that's in this country has that stupid rule. Like if there are 2 commas in a contract, you're giving away your money. Okay, that's the script interpreter of all the consensus rules, which are quite complicated.
Yes. Okay, so I think we've now broken down the problem with script. It's a shitty programming language, or at least it's easy to make mistakes or hide bugs in there and make all sorts of complex arrangements that people might or might not notice, and then your money goes to places where you don't want it to go.
Yeah,
is that the best way? That's the summary, right?
Yeah, and we've seen, in other projects how bad things can go if you have a very complicated language that does things you're not completely expecting. So,
are you referring to a project that rhymes on Ethereum?
Oh.
I think we're on the same page. Yes.
Yeah.
Okay. So solutions. We're getting to the solution part of the story.
So what you're basically doing, what Miniscript is doing, is it's taking certain example scripts, so sequence of opcodes, and it lists, I think, about 20 of them, 20 templates.
This is Miniscript.
Yes.
Yes.
It lists, a few dozen templates. It does not use all of the available Bitcoin script. It uses a subset of it.
Right. So let's say Bitcoin script has 100 tools. I have no idea if
something
it's
like that,
anywhere close to 100. I'm just throwing out a number. The Miniscript says, okay, let's throw out 80 of these because these are just going to cause a mess. And let's keep 20. And that way it's going to be a little bit simpler for everyone.
Right.
Is that right?
Well, if Bitcoin script uses an alphabet, essentially, and Miniscript has a set of words. So it's not a subset of the alphabet, but it's a subset of words.
I see. Okay. That's a better analogy.
Yeah, so there's certain patterns of opcodes that you're allowed to use. And if you use those patterns in the way they describe...
So this double comma is removed now.
Yeah, there's no double comma. Or there is, but it is used in a very precise way. So basically Miniscript, it removes some of the food guns, but it also allows you to do very cool stuff safely. In particular, it lets you do things like AND. So you can say condition A must be true and condition B must be true. And you can do things like OR. And whatever is inside the or inside the AND can be arbitrarily complex. So with Bitcoin script, you have if and else type of statements. But if you're not careful, those if and else statements will not do what you think they're going to do. So with Miniscript,
there's more complexity hidden after the if.
Yes, exactly. And the Miniscript, basically, the templates make sure that you're only doing things that are actually like doing what you think they're doing. So they really contain it. And that allows you to do nice things. So let's say you're a company and you offer a semi-custodial wallet solution where you have one of the keys of the user. And the user has 2 keys, for example. So you don't have a majority of the keys. And maybe there's a 5-year timeout where you do have control in case the user dies. Something like that, right?
Yeah, like a multisig kind of setup.
And so normally when you set up a multisig, the way you kind of set it up is everybody gives gives their key, their master key, their XPub, for example, and you create a very simple script that has 3 keys and 3 people sign. But the problem is, because you're a big business that offers the service, you have some really complicated internal accounting department, and you maybe want to have 5 different signatures by specific people in God knows what complexity. But you don't want to...
Yeah, you have like you have like 5 members on the board, and you want 3 of them to sign.
Yeah.
Unless maybe the CEO
and especially
gets
once
some
we
sort
have...
of special right from 2 of the board members.
And there's a code hidden in an envelope inside the nuclear suitcase that has an override. Exactly.
There's like all sorts of complex stuff you can do with it. And
now,
all the complex stuff should count as 1 key. Like right, that's where you're getting at. Like you don't really care how the complex stuff is solved.
Yeah.
That's up to the company. You figure it out, company.
Yeah.
As long as it's just clear to us that it's only 1 key, however you do it.
Exactly. Now, the problem with that is, if I gave you, you can do that with script or with Taproot, but how do I, as a customer, know, like, I would have to hire my own electronic lawyer to check that script of yours, that it doesn't have any of these double comma little gimmicks in it.
Yes.
And if only there was a way you could check that. And Miniscript is done such that you can check that. As long as the script that you're getting is compatible with Miniscript, because Miniscript to normal script is 2 ways. So you can take any Miniscript, turn it into a normal script. You can take any normal script and turn it into a Miniscript. Well, unless it doesn't match, right? If there's codes in it that don't apply, then it just doesn't compile or doesn't translate.
Sure.
So, and if you can turn something into Miniscript, then you can analyze it using all sorts of tools that can analyze any Miniscript.
Right.
So what you would have is every wallet out there could have a Miniscript interpreter, and the interpreter could show you a little pie chart and saying, you are this one piece of the pie, and there's this other piece of the pie that is really complicated, but you don't have to worry about it. It's not going to do anything sneaky.
Right. That's good.
That's excellent. Yeah.
Yeah. One of the things that we're making a podcast, so we can't actually show this, unfortunately. But Poelstra, for example, like he's drawn this out. Like you can actually draw out what a contract would look like. Apparently, that's not really possible with a script. All of this was news to me when
you can. It's just horrible, manual, tedious. Yeah. I mean, imagine the people from Liquid, for example, that have a 13 of 5 multi-sig with all sorts of fallbacks.
Yeah, okay, so that's probably drawn out at some point. Yeah, but with Miniscript, it's actually fairly simple to draw it out.
Yeah.
And you can show this to a CEO who has no idea about script or Miniscript. He can just look at the picture and figure, hey, that's sort of what I want the blue and red squares to be, and if these keys work out like this, then seems like a good idea to me.
Exactly.
So that's actually possible now.
Yeah, with Miniscript. But wait, there's more.
There's more.
And that's called the policy language.
Nice. Wait, no, I want to get to. I want to ask you something else first.
Okay.
With Miniscript, I do think there are, strictly technically speaking, there are some limitations. Like there is stuff you can't do with Miniscript, right?
Yes.
But as far as I understand, these are stuff no one actually does anyways.
Well, that's not necessarily true. So the thing is, but we have to go to policy language before I can explain that.
Oh, we do?
Yes.
Did you have this in mind already?
So yeah. So let me just quickly explain.
You got this episode planned out way better than I do.
Well, to understand why you might want to do really complicated stuff, I need to explain what the policy language is.
Yes. Okay, go for it.
So a policy language, poorly named, or maybe not poorly named, is a way to express your intentions. So, for example, to say, I want 2 signatures. And this can be translated or compiled, I think is the better term, to Miniscript. And the nice thing is...
So to be clear, the policy language is the stuff, like if someone like you, Sjors, you're writing you're building a wallet, I don't know, you're doing something on your computer, improving Bitcoin, then you're typing and the stuff that comes out of your fingers is policy language. And then you actually compile that to script later on.
Yeah, I mean, you could just write the script directly, or you could write the Miniscript directly. But the nice thing about writing the policy language is that you can have a compiler that can be very smart. So a simple policy language might be just give me 2 of 2 signatures, and the policy language will probably convert that to op multisig, or it will convert that to multisig in Miniscript, and multisig and Miniscript is just op multisig. So that's super trivial.
Yeah. Okay. So whoever wrote the policy language, and I know Peter Ruijle, for example, wrote the policy language for this. It was him. It was his brain basically. He figured out all the best ways to compile this policy language into Miniscript, right? Like he must have somehow figured it out. Then.
Yeah, he wrote a compiler.
See, I don't know anything about this stuff.
That's okay. So basically, you write a policy language. It's like a higher level programming language. Mm-hmm. So if you have a higher level programming language, like I don't know, BASIC, you can say go to 5. I don't know if you've ever worked with BASIC.
Sure. I can't code Hello World. Isn't that clear to you by now?
Well, I mean, Hello World.
I've coded Hello World once, but that's pretty much
okay. But what language did you
code
Hello World in?
I don't remember.
That's amazing. Anyway, so what happens is, usually when you see a programmer looking at a screen, you see something that looks like English, like with words like for and next and yada yada.
Right.
But eventually the machine is just reading bits and bytes.
Sure. No, I understand that part.
So the bits and bytes are very close to what Bitcoin opcodes look like. They're very low level. They're very instructions like put this on the stack, take that away from the stack. But the Miniscript is essentially the same. It's just only a subset of it, but it's slightly more readable, but it's still extremely low level. Mm-hmm. The policy language is slightly higher level. So what you do is you start at the higher level, which is easier for a programmer to write, and then a computer looks at that high-level language and says, how can I write this into low-level machine-readable stuff as efficiently as possible?
Sure.
So in the case of the multisig thing, I might say, I just want 2 out of 2 signatures. I don't care how you do that.
Yeah.
Then the compiler knows that there are multiple ways to do that.
But how does the compiler know this? I hope there's listeners out there that know as little about this as I do, so they might learn something.
Right.
How does the compiler know this?
So disclaimer, I don't think I've ever written a compiler.
Okay.
I'm not that cool.
Right.
But generally compilers know because somebody wrote the compiler.
Well, that was my point. Like it must have come from Peter Ruijle's brain in this case.
Of course.
Right?
Yes, everything comes out of Peter Ruijle's brain.
There we go.
But basically the compiler knows, okay, there's maybe 2 or 3 ways to do this, to execute this intention. And then the question is, which of the 3 am I going to pick? Well, then it depends on the transaction weight and and the fees that you might be involved. But also you can tell it, okay, I think most of the time it's condition A, but only 10% of the time it's condition B. And then the compiler can try, condition A 9 times and condition B 1 time, and then figure out what the expected fee is. So it can optimize for typical use cases, worst case scenarios, all these things. And it can then spit out a Bitcoin script or a Miniscript that then becomes a Bitcoin script.
Yes, the compiler figures out the best way to do something.
And in very practical terms, another thing it could do, I don't know if it can already do that, is, you have Segwit scripts now, but we'll hopefully have Taproot, which can put things in a Merkle tree. So your compiler could figure out where to put stuff in the Merkle tree. You don't have to worry about how to build a Merkle tree.
Right, yes.
So
exactly.
It can do all sorts of things. So you start at the policy language, and then you write Miniscript, and that goes into whatever.
Okay, so that's what a policy language... Well, that's what a compiler is. A policy language you use, so you put it into the compiler, and then Miniscript comes out of it, which is, in a way, script.
Yes, I think the technical term for going from Miniscript to script is transpiling, which basically is like a one-on-one thing. You can do it in 2 directions. So you can go from Miniscript to script, from script to Miniscript, but you cannot go back to a policy language. Well, you can guess the policy language. But
okay, you can. Yeah, okay, I guess so, yes. Yeah. I understand that.
Yeah. And there may even be
and then getting back to... Are we ready to get back to my question about the limitations?
Absolutely.
Okay, so now there are some limitations when you're using, I guess, this policy language or Miniscript in general.
Yes.
But these are limitations that no one actually suffers from, is how I understood it.
Not necessarily. I mean, ideally, yes. But in practice, some policies might be very complicated. And there would be infinite ways to execute these in Bitcoin script. And because of all these weird double comma footguns that are in Bitcoin script, sometimes that's an advantage. Sometimes you can write something really efficiently in Bitcoin script that is just really horrible if you objectively look at it, but it is really fast or really fee efficient. And in fact, I believe Lightning uses that. The way they sometimes deal with time locks or with hashes or nonces. There are some tricks in Lightning, I believe, that you cannot do in Miniscript, or at least that you could not do in Miniscript. Maybe you can now.
Okay.
So there are some optimizations where, like what Polstra said, like, you do some weird switching of the stack and you interpret things not the way they were. You put a public key on it, but you interpret it as a number. Those kind of weird tricks. Those might be very hard to reason about, but a human might be able to do it. But the Miniscript compiler would not do it, which means you end up with potentially longer Lightning scripts if you do not have all the whistles and bells in it.
Right.
So it's possible that Miniscript would be expanded if there is some other optimal way to do it. But you have to be careful, because if you really want to make sure there's nothing in Miniscript that brings back those scary properties of the underlying language.
Yeah. Well, and to be clear, in case this isn't clear to anyone, Miniscript is an addition to what there is already. Like, script is going nowhere. Bitcoin still uses script, and that's the way it's going to be. It's just this is an extra tool for people who want to use that.
And in fact, it's not a consensus change at all.
No, it's
right?
nothing.
It's a tool that you can use or not use. Like, don't worry, it's not Blockstream dominating the script here.
Yes. Okay, so we mentioned Peter Ruyle has this policy language. I know this is very fresh and you probably haven't looked at it very much, but Nadav Ivki also wrote a policy language. You haven't studied that yet, I think,
I have
right?
not yet, so I thought that would be a cliffhanger.
That will be a cliffhanger. You like the cliffhanger, so that will be a cliffhanger for another episode.
Or never.
Or maybe we'll have one of those lost.
But I can tell you from what I know about the policy language is that you're still some steps away from having a practical tool where you and I can set up a very complicated multisig wallet. There's all sorts of questions you want to answer, like how exactly do you do this setup? What are you emailing to each other? Are you emailing your keys, or are you emailing something a little bit more abstract that you agree on first and then you exchange keys? Those very practical things are not solved inside a Miniscript. So
let me at least mention
Nadav.
It's called Minsk. So his policy language is called Minsk.
Okay.
Okay, I'm afraid we can't give you any more info about Minsk yet.
Well, I know Minsk
dear
with a K is a city,
maybe one
but
day.
I think it's with a C. So.
Minsk with a C, yeah, that's some extra info. Yeah. All right, Sjors, is this the end of our episode? Did we cover everything we needed to cover for Miniscript?
I hope so.
It was maybe slightly messy, so let's sum it up. Miniscript is a subsection. No, you called it a template.
Yes, it's a template of script
even
pieces.
The summary is getting messy now.
So basically, Bitcoin script is like an alphabet, essentially, just different letters that have different meanings. And you could see Miniscript as a set of words, not really words because you can put things between the words, but maybe words and brackets and commas. That's what Miniscript is. And then the policy language is the thing that can be converted to Miniscript. It's a bit more high level.
There are several of those apparently by now.
Yes, exactly. Because Miniscript, it has to be set in stone, I guess, sort of, because you want to do all the safety checks on it. But then, just like you can have different programming language, you can have different policy languages.
Yes. So if you're into Bitcoin programming, this is what you want to study. This is what you want to look at.
If you're into Bitcoin programming, the rabbit hole is massive, and pick something. There's a talk by Andrew Polstra.
This one is probably pretty good, though, right?
Yeah, but so there's a talk by Andrew Polstra from Advancing Bitcoin, not the conference, but the meetup before it, the BitDevs London, where he talks for 2 hours about all the problems with regular script and why he hates things. And that's just, he said he was going to do it in 20 minutes, and I think he still didn't cover everything. I don't think that's the best place to start.
He's still on stage.
He's still on stage out there, just going through it.
All right, this was our episode on Miniscript, I think.
Yep. So thank you. Should I say thank you?
I forgot how we closed our episode.
I think I say thank you for listening to the Wirdum Sjorsnado.
There we go.